to warmly welcome our chief guest and the guest speaker of today, Engineer Anupama Silva, for attending here by dedicating your precious time. And also, I would like to warmly welcome all advisors and IEEE branch advisor and all IEEE executive committee members of IEEE student branch of Sri Lanka Technological Campus who joined to today make this session success. I like warmly welcome to you all who come today participate the valuable session. And also I hope this will be the best experience for all of you to learn about innovation ideas and resolving energy crisis. So thank you all. Enjoy the session. Take care and stay safe. Over to you, Sinali.
Thank you, Phelan. Let me introduce you to our exceptional guest speaker today, Mr. Anupama Silva. Mr. Anupama Silva is a chartered engineer with 18 years of experience in the industry. He obtained his Bachelor of Science Engineering degree in electrical installations from University of Moratuwa. In addition, Mr. Anupama holds an MBA degree and had certified as a project management professional by MPMI USC. Currently, he is a researcher in relation to renewable energy sector and had presented his research paper on techno-economic analysis for employing NCRE with hydrogen storage at IEEE ICPES session in 2018. Mr. Anupama, we are honored and extremely grateful to have you as our guest speaker. This online platform is all yours. Over to you, sir.
Thank you and good evening. May I share the screen? Good evening. Hope you can hear me clearly.
Yes, sir, you're audible.
Okay, thank you for the opportunity that you have, for the invitation that the fellow has made to me few days back. And I think the topic that we are discussing today is the cause of the causes of power crisis, as well as the way forward to come out of the crisis. I think there is no any explanation requires why this topic has selected by you. It's obvious. We'll see that what are the causes that which creates this situation over the periods, and what are the causes we are doing to keep the crisis on, and what are the causes of ourselves as the public and the governments, the policymakers, which keeps the solutions away, and what are the possible way forwards to come out of this as responsible citizens. I expect that we can move through the roadmap as I have listed here. If anything to be clarified, you can disturb me in the middle, but I prefer you can utilize the sessions for the audience. That is a Q&A session, which is planned at the end. Then it won't disturb the flow, but still as an educational flow, if you require something to be asked, you're quite free, but I prefer to have the discussion at the end. First, what is the power cut? That in the roadmap is experiencing concern is the power cut, and we can discuss what are the repercussions of this power cut. That may be social, economic, and many more, and also the reasons behind the power shortage that we are expecting to discuss. Reasons in the terms of not social, but it's technical, economic, as well as political reasons are behind the screen, and the possible solutions. That's the main part that we have to focus on. Then almost that even Felon had said that the chairman, you are focusing on get the power generated on by every citizen here. That's so I think it's better it's NCRE again. That means NCRE is non-conventional renewable energy. We'll see that how we can incorporate this NCRE as a solution for this, and what are the challenges and the solutions that we can battle against the challenges. And then it's the time for you to get the session and get something out of me at the session for the audience. That's Q&A session. Roadmap, as of now, we are with the unlit bulb at the beginning of the road. At the end, we are expecting in the very near future, the bulb is to be lit at the end. At the end of the road, we'll see. What is the commercial power supply? First of all, we need to understand it. Then only we can understand, we can discuss what is the power cut that we are talking about. And then only we can go to towards the solutions. The commercial power supply, it comprises of mainly 4 parts. The latter 2 can be considered as one, but here I have segregated those that into 2 parts to understand the scenario what we are experiencing now. The first part is the energy. If the commercial power supply, if it cannot deliver energy which is required by the consumers, there's no point of getting such a power supply at commercial level. The energy is the energy that is what we are consuming. As most of the audience are engineers and engineering undergraduates, that you know the energy is the amount of energy that we are using over a period. And the next important parameter is the power demand of a commercial power supply. The power demand is the rate of energy consumption. That in simple terms, how many bulbs, how many lights that we can light, and how many appliances and what are the wattages that the power of those appliances that we can concurrently use. What is the current that the particular power connection supply at a single time? Those are the factors that we refer to as the power demand of a commercial power supply. And at present in Sri Lanka, according to the Act, there are several contracted packages, contracted connection types that a consumer can obtain from a utility service provider. A single phase 30 ampere connection, a 3-phase 30 ampere connection, 3-phase 60 ampere connection, and above that it goes as bulk. Those are the type of connection. However, the parameter we are discussing here under commercial power supply is the power demand. And the most important part, which 95% of the consumers are not focusing on, is the power quality. But this power quality is a matter, because we are using here in Sri Lanka, it's 230 volts, 50 hertz is the standard that we are using here. The power quality is an important factor because it should be a sinusoidal wave and the pure sinusoidal wave, and the voltage should be within the voltage fluctuations should be within the permissible standard which the standards are allowed, and also the frequency should be maintained at 50 with the deviation of just 0.5 hertz plus and minus. And the other one, that even though a commercial power connection fulfill all of these 3 parameters, what is the purpose of it if we do not have the connection available at the point of time which we require it? Then that is the factor we call as availability. Say, for example, a mobile phone connection, which all of us have in our pockets, and we carry where we go. There may be very advanced technologies that deliver through the services, advanced services delivered through the technology. But at a point of time which that emergency is there to get a telephone call or search the web, if the connection is lost, then what is the situation of the user? What is the situation of the subscriber? That is availability. Even though a very minimum energy that we are using, even though a very minimum amount of power we consume, what the consumer expect is the freedom to use. That means at the time which he requires the connection, it should be available with him. That is the availability. This is the burning issue as felt by the public with this power crisis. This is what we are termed as the power cut in our normal term. The power supply, the commercial power supply, which we pay the bill to the utility provider, but they are all failing to provide the power supply, the availability of the power supply to the consumers when they require it. And that means the degree of freedom to use on our discretion is reduced. That means the degree of freedom of usability is reduced. That is what we are referring it as the power cut. And this is the factor out of all these four parameters which we are losing within this era of the power crisis. There were some periods which the particular power quality was not there because of in some areas there were, in some 1.5 decades ago, there were voltage fluctuations, voltage drops because of the generation shortages and the losses in the transmission and distribution networks. This is the story 1.5 decades ago, but as of now, those have been normalized, and the good network is there, but the availability is the drawback that we are experiencing now. In such a way that we will see that when it comes to the availability and loss of losing the availability, it is not a situation that we lose the degree of freedom for usage, but it is not available at the most important time. In the coming slides that I will explain what is the technicality behind losing the power, that imposing the power cuts within the most important times. There's a technical reason for that. It's a very simple reason. We'll see. We'll see what are the repercussions of power crisis. Basically, at the beginning, I told that can be segregated as social and economic both. What are the social repercussions? Inconvenience. Very clearly, we see when the power cuts are there, we will definitely have a disruption within the period of 6:30 to 10:30. That's the peak time. Then, and that is the most important time which we requires the power availability, power supply. And in the meantime, we are having another window of the power disruption within the daytime period, which the officers are working. Fortunately, there are two windows. Somewhat it is the inconvenience was reduced. However, it impacts the commercial productivity. That means the productivity of the industries and the product, even say for example, to the students, the school students, the university students, and all the other works at this home are disrupted because of this power cut, and then it leads to the low productivity. And because of this, we experienced 4 or 5 months back, the social unrest was peaked because of this bad experience with the power cut, when it goes to the 10 hours per day, 12 hours per day, and so on. And those will disturb the calmness and the peaceful society, and it leads to the social unrest. Those are the social repercussions at large, but there are maybe some small other areas which should not be our focus at this session, but those are also concerns and the repercussions of the power crisis. And when it comes to economic, these are chain effects. When the social repercussions are there, it impacts the economic and economy, and the economic repercussions will again in turn will impact the social repercussions as well. Interruption to the production flow. Say for example, how we earn our foreign exchange. It's through the industries, basically in the export industry and the garment industry. So those flows will be disturbed with the power supply failures. And also, say for example, there are some industries which say like the rubber products, glass products. Those industries require continuous power because they use the molten material. So the material to be maintained at that state of the solidity, it requires the power to be uninterrupted, and otherwise the loss of materials will be there with the substantial commercial losses. So the production flows are interrupted. For some industries, those entrepreneurs decide to get the power source through other alternate sources, but it is at a higher cost. So again, it will impact to the prices of the products. The cost of production, it goes up, and hence it impacts the prices of the products. Say, for example, you will realize that within today, it was announced that even the telecommunication service prices of telecommunication services, which is the only commodity which the prices came down even with inflation, even with the devaluation of the rupee. That is the only commodity in Sri Lanka which the prices were keep reducing for last 2 decades time, the period over the last 2 decade period. But yes, today or yesterday it was increased. The basic reason for those are the increase in the cost of production. Production is not the production, it's a service, but the power is the lifeblood of the industry. So that is, such things are possible, not only for the production industry, but the services industry as well. Industry like telecommunications, which the prices had been kept reducing, had to be increased with these things. Those are the economic repercussions that we will see with the power crisis. The demand with the price increase in the price, the demand drops, especially not limiting to the local markets. The worst part is that we will experience a drop in the demand in the export markets for the products that we are exporting to earn forex for the country. In turn, it will again with the chain effect, it will impact the power prices of the power production as well. Also, that if say for example, take one of ourselves as the example. If we are planning to go for a leisure tour within the Sri Lanka or any other country, do we prefer to have a power cut within our time of leisure period? No. So say for example, whether the tourists who are coming from the other countries to visit Sri Lanka, while they were at the hotels, are they willing to have a power cut experience without the power? So the answer is very straightforward, is no. But these will be economically, we will face this with the negative essence in the tourism as well. And all these issues, all these repercussions are not single repercussions, though those are impacting our lives and the economy and the society at large in a chain effect. Let's see what are the reasons behind these present power cuts. Basically, let's segregate it into two. The first, let's talk about technical, what we can make some impact. The economic, yes, we can make an impact, but it's at a very higher stage. We'll see. In the technically, we are experiencing two shortages. One is the shortage of energy. The other one is the shortage in power generation. The power cut is basically because of these two. But at this time, basically we are experiencing this power cut because of the shortage of energy, not the power generation shortage is also there to give the power demand, but basically it is energy. You from the media as well that you might got this knowledge. 1 or 2 diesel power plants in some power canalities is not working because of not getting adequate diesel. And there were some news that there was a threat or there's a risk of getting coal to run the coal power plant as well. But however, the news was not that bad. It is moving. Because safer is the reason for the energy shortage is we are not getting enough fuel. That fuel in the thermal power plant, the fuel is diesel or naphtha, that means heavy oil or coal. But for the other power plants, which we are using as hydro, in some terms, the reservoir, the water reserves in the reservoirs are the fuel for those power plants. Very recently we are getting rain, fortunately we are getting rain, unless those power plants are also with lack of fuel, that is hydro. The major reason is this shortage of energy. We need to keep this available fuel reserved and to plan for a longer period of availability. So that is why the main reason that we need to impose a power cut to the consumers. The other one is the shortage in power. This is what we have experienced 2-3 years ago. The power generation, the installed capacity is not enough to provide the required demand. That is why majorly we need to have a power cut. Until this point of this power cut that we are experiencing since February this year, earlier the power cuts the reason was the shortage of installed capacity, operable installed capacity, where we cannot meet the required power demand, which the energy to be consumed within a given period. That means the amount of power we deliver, which is measured through kilowatts and megawatts. The energy is the commodity, the parameter which we are consuming and measured through the kilowatt hours. The kilowatt hour, 1 kilowatt hour is equal to a unit which we pay. That is the amount that is the parameter we use to pay to the utility provider. Then the other are solar and wind solutions for this. What do you think? I think it's a long, somewhat lengthy discussion. Yes, on slide 10 onwards that we are discussing on that to a certain extent. We'll see. The other one is the economic reasons behind the power cut. Again, I'm coming to the technical reason. I told this technical, economic, social, those are not very isolated terms. The linkage between those areas are always changed. The technical reasons are impacting the economical reasons, and economic reasons are in turn again impacting the technical reasons. That is why we need a proper plan and done by the experts in the industry and the people who have get trained and with the knowledge and with the foreseeing ability for the future, and the expert professionals are required. Not every Tom, Dick and Harry can do this. That's a very simple thing. Those are chain effects. If we get something wrong at a single point of decision, it will impact with the chain effect in every area. When we are talking about a macro plan, that is the nature of that macro plans. That is why every Tom, Dick and Harry should not be allowed to take decisions on these very sensitive areas. The economical, it comes to the lack of forex. Forex means the foreign exchange, what we are referring to as in normal day-to-day terms, it is the US dollars that we are telling us that we are in short of. However, even though it is USD, it is any other dollars, or it is the authorities is basically the government, and are not taking measures to implement it. They, in time to time, the governments are changing their policies, and they need to change it. But a long-term national generation plan cannot be changed every time. If it is required to change, the engineers can take decisions to change it. But if the people, the policymakers are always just keeping it's changing, but no any action is taking on the ground, then there's no generation, but there are only several generation plans. Say, for example, you just imagine the last major power plant was commissioned in 2014. That means the third phase of Noracholi, the Lakvijay plant, and the first phase was commissioned in 2011. And since 2014, for 8 years, as of now, it's 2022, no major power plant has commissioned. But see the demand, that how the demand has increased, and how the population has increased, how the industries have been developed, and the demand side has increased, but the generation has not been upgraded since last 8 years. So those are the reasons led by political and structural issues. The other one is the cost-effective proposals were cancelled and delayed. Say, for example, the one with the power plant which was about to be started was Sampur for 500 megawatts. You believe one phase and one machine at Noracholi is just 300 megawatts. The altogether is 900 megawatts is serving to the grid by at 900 megawatts. It takes nearly 90 megawatts for the auxiliary power, and 270 each. It is delivering to the network. But this Sampur, only one power plant, it is giving 1 megawatt at one. So it was cancelled. Those are not done by the utility providers. It is not according to the generation plan, but the political and structural issues had led to those. One other means, even the public is responsible for this, because the political structures are appointed by the public, not by the engineers. And the Noracholi 900 megawatt, even this 900 megawatt, it was implemented in 2011. It was to be done in 1996. The proposal and the plan was given by the utility provider in 1994. You just imagine, even most of this audience had not even born at that time. But it was delayed for 15 years. Throughout these 15 years time, what happened? We fired diesel. The diesel is the most expensive fuel which is used in Sri Lanka to generate electricity. So throughout all these 15 years, without coal, what we have done, we have fired diesel and paid dollars for those diesel. Those dollars will not come again because we have fired it, we have burnt it. At those days, still the coal is the cheapest energy, cheapest fossil fuel, which we can take. The countries who are in the developing stage are using coal because we cannot afford the other means. LNG is also is clean energy, but in terms it has cost for the plants. The gasification and decasification plants are with very high capital investment. So again, the capital investments are to be depreciated and included in the tariff as well. But however, we are not ready with this LNG. These are the underlying reasons for these power shortages because of the political and structural issues, which are done by, the decisions were taken by all Tom, Dick, and Harry's. We say as in other terms as well, but not even without taking the engineers' advices properly. And some other terms, if we tell for 15 years, if we could use coal to generate this 900 megawatts instead of diesel, we should not have a shortage in foreign exchange as of now, because we have already lost such very considerable amount of foreign exchange for diesel over these delays. Even now we are firing diesel because we do not have cost-effective power plants to be run. The other one is the weakness in regulatory function. The regulatory function, they say, for example, that I told the telecommunication. Telecommunication is the only commodity that we have experienced a price dip, reducing prices for last 2 decades, that 20 years time that we are experiencing. The cost per unit is being reduced. How it happens? It happens, the telecommunication industry has a very good, strong and knowledgeable regulator. That's the TRCSA. It regulates it very well. Unless otherwise, how Sri Lanka, the smallest, one of the very small countries in the region, is that country is the always first to come to market. In GSM, in 3G, in 4G, everything, Sri Lanka is the first to launch in the region, South Asian region. How it happens? It happens because the industry has a very good, knowledgeable and strategic regulator, very strong regulator. That is the reason. But what happens in the power industry? The regulator, he just approves the time to the power cut duration is approved. But it always, there are grudges between the utility provider, government, and the regulator for the generation plan. I have not seen the tariff are aligned with the national economic situation. The electricity tariff are not aligned with the national economic situation. And the generation plan, approved generation plan, is the tariff is not aligned with it. So those are the weakness of the regulatory function. If the other one, I think all, as everyone are the engineering undergraduates and the engineers, you know what an op-amp is. In an operational amplifier, op-amp, we cannot just give the signal input and get the output. Then what happens? The output is get clipped and the output get unstable. How we stable an op-amp? The output of the amplification of the op-amp. We just give a negative feedback path. Even a control system, we have a negative feedback path. Without a negative feedback path, no system, no practical system will sustain. For a practical system to be sustained, there should definitely be a negative feedback path. In the economic terms, the best negative feedback path is designed through the term called the price. When a commodity has a higher supply than the demand, then what happens? The price goes down. That is the negative feedback path given to the manufacturer. You have to reduce it gives this message that you have to reduce your supply. Unless your prices will go down and your industry will get crashed. On the other hand, when the supply is less and the demand is high, then the feedback gives as the price to be increased, price hike. But what happens here in the electricity tariff? The tariff is approved and decided by the regulator. But regulator does not have the pressure of generation cost. Because it does not, I can't say that they do not have the knowledge, but they do not have the pressure of that cost. So if the tariff design has the knowledge and the pressure on the cost, definitely the tariff should get, the tariff will be get the sense of that cost. Here in our tariff, we have ample amount of subsidies. giving the subsidies means the people do not get the feeling of the cost pressure. So the expected reduction in the usage will not happen. So that is why I told the regulatory function needs to be more sharpened here, unless this crisis will not be rectified for several decades. It will continue forever. Say, for example, just take many other in the best industry for this regulation is telecommunication. Always the consumer gets the benefit, but still the suppliers, there are private organizations in the telecommunication industry. They are making their profit. They have the pressure of cost, and they do the innovations. They take novel ideas, and they reduce their operational costs as well, and they manage it. But their tariff is getting reduced. The consumer in turn get the benefits because of the correct coordination function of the regulator. Say, for example, if you go to the transport industry, I think the two industries which we should not compare one-to-one, telecommunication and transport. Telecommunication industry, it gives a superb service to this consumers, but transport industry, I do not want to measure it. But however, see, there is no proper regulation. Regulations are there, but the regulatory function is not there. Regulations are there. Then what will happen? The consumer will not get the proper expected service out of it. Here is as well. But however, what the tariff or whatever the public utility management is done in regulations are imposed, whatever, finally Sri Lankan consumers, Sri Lankan energy consumers, electricity consumers are not getting a 24 hours available power system as of now. But in some period we were boasted as we were the only nation in the region, in the South Asia, who provides 24/7 power supply for 98% of population. We were in such a position at the time of once Norotchole first phase was commissioned. We were at that position. We were at the same as the telecommunication industry in the region. We were the first to launch new technologies. In the electricity power section area as well, we were leading the region. But now what happened? It is because of the engineers' plans, engineers' advisors are not taken into serious consideration. That is the reason that we have come to this situation. The problem in basic technical terms, it's very simple. Demand is higher than supply. As I told you earlier, what will happen if the price, demand, supply, those are in the free market. If it is given, what will happen is, if demand is higher than the supply, the price keeps increase because the cost of production is to be felt by the consumer. Then the consumer keeps this demand at a lower stage, and then the equilibrium takes place. Then the demand matches the supply, and we will have a stable price structure. That is why I told this: the tariff has not designed properly. The tariff is very worst, and it is one of the major reasons to lead the power crisis to this situation. Here, demand is higher than the supply. Demand in terms of what? What is the energy? The other one is the power. I think as engineers, I do not want to explain what is the again this. I have explained it earlier. If someone requires, yes, can. And what are the required immediate actions to come out of this situation? Immediate. This is not short term, medium term, and long term. These are immediate actions. Energy. To energy, if energy demand is higher than supply, only option we have to do is reduce the consumption. Let's see what are the ways that we can achieve this reduction. The other one, power. If the power demand is higher than the supply, only option at immediate stage is clip the peak. What it means by the clip the peak? Clip the peak. I think you can see the graph here. This was taken from the ZB long-term generation plan. This is the change in daily load curves over 8 years. These are the years. You see, there is a, when compared to 2013, there is the peak demand has increased by nearly 600 megawatts. But what I have told was, for last 8 years, we have not commissioned a major power plant. So here this picture, if one very consciously read, the entire reason for the issue is here. One can take it out of this graph. Okay, let's come to this explanation. What is this clipping the peak? This is the, say for example, now we are in this very similar to this 2020 curve, because now industries were developed within last 2 years because of the COVID-19 pandemic hit and everything. And see this yellow curve. There are two locally given the peaks. These peaks are the higher demands. When clipping the peak means we have to stop delivering the required demand at this peak time. See, this is exactly what we refer to as power cut these days. At this peak time, we are clipping the peak. We are disturbing the utility provider does not provide the peak demand at this peak time for certain areas, and it keeps the power distribution limited. Obviously, chops make by clipping of this, it chops a substantial chunk of energy demand as well. Not only clipping the power. Here, as I told you, as of now, we do not have a shortage in installed capacity. We have the installed capacity, but we have an energy crisis because we do not have money to buy fuel to energize and run these power plants. So we have an energy crisis. So why we need to clip the peak, not this flat area? The higher amount of energy can be reduced or saved by clipping this peak, because say for example, it is obvious one, the energy delivered is area under this curve. This is the power curve. The energy delivered is area under the curve. So if we need to save, say for example, 1 gigawatt hour to be saved, if it is to be saved by cutting the power here in this flat area, say for example, it will be 1.5 hours by cutting 45 minutes or cutting 1 hour within the peak will save the same energy level. So this is the basic understanding of the basic problem in basic technical terms. Possible ways to come out of this. We'll segregate it as two. One is demand side management. The other one is the supply side management. The demand side management is to control the demand or manage the demand. Here I take the responsibility and the actions that what we can do by general public. That means ourselves as responsible citizens, what we can do. And policymakers, it's separate. That we have to let them do and pressurize them to do. But first, we have to do it by ourselves. If we require, yes, we can. General public, what to do? Optimize the consumption. We can switch towards efficient appliances. But do not argue with me at this time. How can I change my refrigerator or change my air conditioner to a inverter type 1 because the cost is high. No, that is a separate thing. But there are possibilities and there were possibilities. Say, for example, there are houses still we have who uses tungsten bulbs. The tungsten bulb, the efficiency is just 5%. It delivers from a 100-watt tungsten bulb, which gives the yellow light. It provides only 5 watt of light. Entire 95% goes as heat. So if we move to LED or CFL, the same amount of light can be taken by a 5 or 7 watt LED light would serve. So we are saving 93% of energy of which we have entering for a tungsten bulb. So those are the ways that we could have done. Some people have already switched to this, but there are some. Why the other people have not switching to these efficient appliances earlier? Because the major reason is why they should buy or replace a 80 rupees bulb worth, tungsten bulb worth of 80 rupees by an LED bulb worth of 500 rupees. What is the use for him? He does not have a use. He does not feel a pressure of energy cost, because his bill is paid by some other. His electricity bill is paid by some other because there are subsidies. The tariff does not reflect the actual electricity cost. If the tariff has the actual electricity cost, people would have switched from these low efficient appliances towards high efficient appliances. It's obvious. And the conscious and responsible usage. Say, for example, what is this? Conscious and responsible usage. I have seen earlier days, not at this crisis days, utility provider and some social responsibility campaigns, and those, they say, just keep your clothes ironed at once. All the clothes to be ironed, our dresses to be ironed for a week. Do it at once, not one by one. Why it is saying? For every time we are switching on the iron to iron a dress, there is a time that the iron is taking to get heated. If that particular iron is with 1,500 watts or 200 watts, generally nowadays the electric irons are at that scale because we need to save time. But however, for that particular 1 minute or 2 minute time, that iron uses 200 watts. Every time we switch it on, yes, it happens. But all the dresses, say generally for the office dresses that we are using for the entire week, maybe for an entire house, there may be 30 or 40 pieces of dresses that we have to iron. If we iron it at once on a single day, this heating time, the appliance heating time, is only once. Every other thing is the usage. But if we get this ironed for 30 times, the 30 pieces are ironed for 30 times, this heating time is increased by 30 times. So if we can consciously do it, yes, we can. If we can switch the refrigerators off within that peak period, it won't save time for us because we are not in the time of use tariff. If we are in the time of use tariff, yes, that is best. But if we are in the general tariff structure, so if we can switch a refrigerator off for 2 hours within that peak 4 hours, it will help the grid to generate less at that time. Because, say, I'll go to that graph, I'll explain it here. This higher peak, at this time, the utility generation is generation is done by every means of possibilities. That means not only hydro, not only coal. At this time, all the diesel generators are fired to meet this peak. If we reduce 1 unit generated within this peak, if one citizen reduces 1 unit, that means that person is reducing the cost of generation by 1 unit, and that unit is reduced from the diesel generation. Diesel is the highest costly generation. So the utility provider can reduce that generation from the highest cost source. So yes, every single citizen can do this. We have the power because we are the demand side managers, not the utility provider. The way the utility provider can do is cut the power, but that is not what we expect. And that is not the country or the nation expect from us. At least these educated engineers, if we can reduce 1 unit by 1 person, say for example, 100,000 people reduces 1 kilowatt each within that period, how many rupees we can save? In turn, that is diesel. In turn, how many US dollars for the fuel bill can be reduced to the country? That is the way the responsible usage. That is what I have mentioned as responsible usage. I am proud to say I am doing this. This will not give any personal benefit to me in rupees. In the sense of rupees, it won't give a single rupee benefit to me except the electricity bill. Still, it has the subsidy. So if it is rupees benefit I am getting, it is a very less amount. I do not care on that. But I am doing this responsible usage. Responsibility is I am doing this because I know that is the point that I can make the highest impact to the grid and the society. Say, for example, if I save $2 for 5 days or for $2 for 1 week, I am saving more than that as of now with this crisis. I am contributing more than that, not with any other thing, but changing my usage patterns. So I am proud that I am helping some other person who requires the medicine. Those dollars can be used to source medicine for the hospitals, medicines for those people who are in need. Rather, I am experiencing a very irresponsible, comfortable life. But I am experiencing comfortable life, but I am having it with the responsibility. In the responsible behavior I am doing. So I urge these very educated and thinkable, intellectual people. There are 48 as of now with me. There are 47. If 20 out of this can practice this, it will make an impact. Or if your other family members or your friends can do this, yes, there's an impact. We can do it. Not rather waiting the policymakers' actions to do it. Yes, as citizens, we can. If we do it, that benefit is for the public, for us itself in turn. I am proud that I am in that thinking. So I am very proud that however my teachers and my parents have given that thinking to me. So I am proud of that. I am doing it not for the benefit of any single cent. I do not take any single cent of doing it, but it adds value to me to as a responsible person, and I don't care even any other cares that value. But I am sure my children, they know that, and they are also practicing like that. So that is a pleasure to me. On the other hand, the distributed demand rearrange the work pattern. If you have a washing machine which is automated, which can be run as programmable, program it to be run in the night. Night means after 12. Yes, when you are waking up in the morning, yes, the clothes are ready. We can do like this because at that time, let's come here. At this, within this time, see, the demand is very low. is just about 1,500. Here is 2,500. No diesel are running at this time. 900 from coal and other hydro are sufficient enough to use at this time. So we are using the electricity for the washing purpose at the lowest rate that we can afford. I think you got it. As engineers, it's very obvious. So very small things adds a large impact. That is the beauty of engineering. If we can see it in an engineering eye, yes, we can do many things. We do not need to do very harsh things, very big things to create an impact. The small things by many people can make an impact. Then let's come to the policymaker side. What policymakers can do to optimize the consumption? They have the people, they are the authorities to impose a proper tariff structure. But yourself or myself cannot impose a tariff structure, but we can do our part. Let's come. Let the cost fall to the consumer. If the consumer feels the cost, the consumer is pushed to take the measures which you and me are ready to take on our own, on our discretion from today. We are ready to take those measures today, as we are knowledgeable, as we are responsible, as we are educated, as we know that we are ready to do. But there are some other people who do not do that. Then the policymakers are the people whom to push them to do it. If they feel the cost, they will do better than ourselves. So that is policymakers. Say for example, if there are people with value, they do not drop a single paper or bus ticket or a toffee wrapper on the road. They are disciplined. But those people are assets. But there's no point if the other, some uneducated or mischievous people keep doing it. So that is why the policymakers should be there. Then they can stop them by the policies. But ourselves, we can refrain from by doing it by our policies, our own policies. Those are the values, but the others are low. So the policymakers are to impose the proper tariff structure and let the consumers feel the cost. Then they will reduce it. As I told, when the price is high, the demand gets low. It is very clear. When the price is high, demand lowers. And then it will come to an equilibrium. If the price is low, who cares the demand? They do not, people do not think like that. So the actual cost should be felt by the consumer through a proper tariff structure. That is up to policymakers and the appropriate public awareness. That is the worst part I have seen at this crisis. I have undergone, because I am now with a considerable age. So the first power cut which the nation has experienced with the shortage of, at that time, not the shortage of energy, at that time the shortage of installed capacity, the first power cut we experienced in 1996. 2 months after winning the Cricket World Cup, we have experienced the power cut. At that time, and then later on, again in 2001, we have experienced the power cut, and 2001 and 2 both. We have experienced the power cut. At that time, I was in the university. Every of these times, there was a very great public awareness to reduce the usage. Even I remember in 2002, the awareness was there to, that's not a law imposed, but requested public to reduce the lighting on the hoarding boards and the banners, the advertising banners. People responded to it. It's a very happy thing that people responded to it. At this time, I never seen even any of the party any of the party means the some social responsibility organizations and the utility providers and the governments are not aware, making the public aware, requesting to do so. So that is the one part that the policymakers should do. On the other hand, they distribute the demand, they motivate the consumers to rearrange the work. Again, the values that I have to general public on their own, they can do it. If they are not doing, the policymakers can move it. Policymakers can motivate the consumers to rearrange the work pattern. How? They promote the time of use tariff through the tariff itself. If the tariff is given so that in using the time of usage, the cost, so the people will move towards it. So that are the measures that we can take. But however, if the public is aware and public thinks in the constructive way, as I do, then policymakers has very less to do. But however, even the policymakers do it, the control of the consumer side, the demand side management is with the public. Consumers hold the greatest control in demand side management. If even the policymakers do not do it, we can do it in our own. So the awareness is the best. That what I have done here is also say, if these educated but bunch of people, the cream of the cream, they are engineering students here, Sri Lankan engineering students. If we can do this, it will be a great impact towards the positive side. And the supply side management. That is generation. Transmission and distribution is very less we can do. This is the point. In the supply chain management. So supply side management is generation. Here you see what I have done. In this demand side management, the general public, the responsibilities and the activities possible by general public is kept at first. And the policymaker's responsibility says I have kept in second. But here I have interchanged it. I have taken the policymakers first and general public second. Why I did so? Because the policymakers hold the greatest share in generation plan, not the public. You and me, we can give our ideas, we can just, as engineers, we can do some innovations and say, and some awarenesses as well. But the policymakers has to do this. It is not what the lagging here is the policymakers lagging. Engineers has done their part. They have prepared the generation plan. They have insisted it. They have explained it well throughout the last decade that they are doing it. But the policymakers are the people who are not doing it. Someone has raised the hand. Do you need to disturb and ask something?
Mr. Anupama, I'm having a question here. Can I ask it now or later?
It's okay.
Yeah. So, as you suggested here, if you make a proper tariff structure, it's very likely to increase our electricity bill, right?
Yeah.
So, then again, it will be a ripple effect on people's unrest again. So, how come we overcome that thing? Actually,
that is why I told any decision, Prasanna, we are taking has a chain effect.
Yes.
At this point, the entire elephant has gone and only the part of a tail is remaining.
Yeah.
So there are many things, there are many repercussions possible, but anything is better, I think, than we are losing the final drop of fuel and the final drop of light is gone without doing it. I think there should be a great awareness to the public, and that is why I told the public has the control. If the public has aware well, and if we understand that what is the situation that we are in, most of the people will support it. Say for even at an organization, if the management of I am not talking about the government organization, so any other, I'm talking about organization filled with many intellectuals, that means the educated people. Say for example, if that organization is having some losses, they are incurring some losses, and they need to take some drastic changes in the warehousing or their electricity usage, or even from the paper usage, then they need to cut some cost. If the CEO of that organization can come to the employees and tell that, hey, colleagues, that we have this problem. If we run like this, that we will incur like this. So in that case, we need to reduce the cost of these areas. I need your suggestions, and you also, I also give some suggestions, but I need your suggestions and support. Let's start from this. And next month he will come and say, yes, we have achieved this level of saving like this, but still it is not enough. We may need to reduce some furthermore. So if please do not take the overtime if it is really not necessary, and we will have to impose some limitations and restrictions for those things, and still people will understand it. But some of the people, there will be 5%, 3% people that who do not understand. But when the 97% are in the other side with the understanding, they do not have that any other option to do. On the other hand, later on in the next month, if he comes and say, yes, we have achieved this. With this progress, we will be able to come out of this problem in another 8 months or 10 months. But I have a bad news to tell you that next month, this year, we will not be able to pay you our bonuses. Still, people will take it. Prasanna, I think you got my point. The awareness, that's why I told that here, public awareness, the appropriate public awareness is a must here, because this is to be done by the public. The public is the one who experience, who use everything is by public. The policymakers has to guide them, not to impose the laws and do everything, but it is a joint hand-in-hand work that we have to do in this matter. I think I am clear with you, Prasanna. And you are also clear with me.
Yes, thank you very much, sir. I got the point. Actually, the people need to understand the situation, and they have to keep a part of this thing, actually, no?
Yeah, Prasanna, actually,
yeah.
I am not believing that people should. Policymakers should, and people will do it. It's the responsibility of policymakers to make the people aware. I don't think that everyone is aware on the crisis to this level. So it is policymakers has to make the people aware, and then people will, majority of the people will basically support it, because the bad experience we had within last 4-5 months, no one is willing to have it again. So people will support it, and the increase in the tariff, increase in the price will help our topic as well. I'll explain it at the next 2-3 slides. May I move forward, Prasanna? Okay, we'll move. This is the policymakers' responsibility in the generation, is to execute the affordable and cost-effective generation plans. As I know, there are prepared generation plans in that way, affordable as well as cost-effective. The issue here is that those had not been executed for last 8 years. That's the reason. For this, the policymakers has some other responsibility, that for how these to be evaluated as affordable and cost effective with initial capex and recurrent opex. Capex is the capital expenditure, which are incurred once and depreciated over the time. Say, for example, a power plant can be depreciated over 1 or 2 decades time, so it will be a very small. But the recurrent opex is the concern. OPEX, once OPEX we have committed to for a particular OPEX portion, it is forever. We have to do it. If we install the diesel power plant, the OPEX is very high, and until the diesel power plant is operating, we have to incur that OPEX. that is in dollars. And every month we have to pay. Every year we have to pay. But a coal power, if it is a hydropower plant or coal power plant, the less OPEX that we incur. Unfortunately, the best is hydropower plant, but there are no any other option that we have, location that we can implement a hydropower plant, because all are utilized already. We'll discuss it at the renewable energy section. And initial capex. This capex and opex, if to get some idea, I'll give some example. The initial capex incurred for the first phase of Norachur, in the Lakvijay power plant in 2000. It was started in 2006 and commissioned in 2011. The capital expenditure, the initial cost of implementation, capex, is $450. Still we are, even the voice which I speak here is heard by you, is audible to you because of that power plant. Because if not, I am definitely, most of us will experience a power cut as of now as well. So what is the amount that we have incurred for that? $450. Do you know what is the fuel bill for month of July? $500. Every month, $500. The target is to make it half by using this quota system. Now, I think you will understand what is the impact of having capex and liability of OPEX. OPEX, every month you have to pay it. Don't forget that $500 or something nearby that fuel bill for month of July is not only for the car of fuel or car of mine, for the buses, for the school vans, trains, and the generators run for the industry, not only for that. It is for the diesel fed to the generation of electricity by the utility provider. Why it is that so? We were short of 500 megawatt coal power plant, and we are using diesel to generate the matching between them. Still, we are incurring power cuts. We are paying, but incurring the power cuts. That is the nature of this capex and opex. If we have implemented those low cost, cost-effective, affordable power plants, we could have reduced that opex fuel bill per month by a drastic, considerable, substantial portion, and reduce the OPEX. OPEX or CAPEX, what we have to earn and pay. CAPEX, the beauty of CAPEX is not that. The beauty of CAPEX is we get it and install, and it is depreciated over a period, and the cost per unit is very less from the CAPEX portion. But OPEX is OPEX. Not only the fueling, but maintenance as well. It also has, but what is I put it as what is the recurrent OPEX? Understand the recurrent OPEX. OPEX is that's one. The other one is the policymaker responsibility is the facilitate generation, general public for self-generation. That means have a solar system in every house, or where possible, if someone is willing to have a wind power plant or solar park and supply electricity to the utility provider, such thing, the government, the policymakers, is better to facilitate. But it should not be done because of a hype, because of the pressure of the hype making people. It should be in line with the forex policies, because the solar panels, inverters, and those things, and batteries are not manufactured here. The raw materials are not here. We are importing it. For those importations, what we require, we need forex. So these facilities, the facilitation is to be in line with the forex policies, because we should have a policy. I believe that at least now have something, and through financing facilities. Say, for example, one of my friends even today talked to me and tell that I am willing to have such a power plant, solar panel, but it is not viable. because financially it won't recover. Why is that so? Because the financing facilities are not that aggressive to motivate people for those things. If the bank loans at a very low interest rates are given, then there are ways that the return of the investment, ROI, return of on investments, are calculated. The most sophisticated and the accurate one is IR, internal rate of return. I think under that you might know or might not know. The IRR has several ways of calculations. For a particular project, there may be IRR. The perspective of project, the incurred cost is to be taken, and the cash outflows and inflows are considered, and the IRR is taken. And if there's a banking facility is given at a concessional rate, then the particular investor, the project, not the project, but the perspective of the investor, then the investor is putting money, a portion of money, and the bank is facilitating the rest. Then the investor's investment is the equity, investor's equity. So that is calculated as the equity IRR. When the financing facility is there, the equity IRR is always higher than the project IRR. And the investor is always worrying about not the project IRR, the equity IRR, the amount of money he has put into the project. He is considering on that. So that is why the financing facilities for these projects are very important. And is procedural framework the most complaint, the largest, very frequent, and the volumistic complaint is the procedural framework to get these self-generation facilities are very cumbersome. So I think policymakers has to keep their eye in and identify what are the reasons for these difficulties and everything, and create some innovative policies to get the public as involved with the self-generation. And the other one is, what is the general public's responsibility towards the supply side management? This is the most interesting thing, I think. For me, I think again, yes, public has the power. I believe like that. General public, the conscious and responsible citizens, that the general public to be behave as conscious and responsible citizens. They have to majorly stay away from misleading by myths. There are several myths in this. We have to get away from this. Let's discuss. To support the long-term generation plans. Say, for example, if some of the people have not disturbed the implementation of Norocchole and let it drag for 15 years, we would not have been in this situation. If the people have not made their voice against the Sampur power plant, the 500 megawatt coal power plant, we would not have, definitely would not have experiencing this power cut. It's obvious, very straightforward. So this is our responsibility as general public. Then why this myths matter come? Because people object this because of the myths. If someone, if we ask that if we discuss on fossil fuels, coal and everything, and discuss and ask from someone which color the carbon dioxide is, nearly 40% will answer as it's black. But in the school days, I have learned that carbon dioxide has no color. But that's the back of the mind image which the people has in the society. All are not educated people. So people think, I believe, I wish that at least 20-30% of this crowd has visited one of the power plants. At least one, that may be solar park or hydro power plant, and even our Norocchole, Lakvijaya coal power plant. I believe that you may have visited, or I think you could have visited. You can visit and see. There is no that such a black color emission is there. There are repercussions, but those are to be evaluated and decided. Say, for example, what is the most polluted city in Sri Lanka? Is it Puttlam? No, it's Colombo. Is it because of the power plants? No, it's the vehicles. But the pollution by numerous amount of vehicles is higher than that generation of 900 megawatts. even the forums for reducing of greenhouse gases, they do not ask the nations to switch between the generation fuel, switch between the sources. That means if we are using coal, they do not ask us to move to LNG or to diesel. If we are using diesel, they do not ask us to move towards solar or renewable, fully renewable. They do not ask like that. But they insist is to improve the efficiency of the usage. That means use electric vehicles rather fossil fuel, or use hybrid vehicles. That is those are the high efficient usage, efficient appliances. That is the one that we should do and make our usage patterns efficient. At any nation cannot afford such a switching between sources. So what we have to focus on that. Those are the myths that we are misled. So people are against some high level generation plans by coal. They do not know. Say for example, in India, they generate nearly 150,000 megawatts using coal. Here at Putlam, we generate, in Noracholi, we generate 900 megawatts. Say for you just imagine, we do not need even this 900 megawatts to get our environment polluted. That 150,000 megawatts generated in South India is more than enough to generate our pollute our environment. That is the big picture in the world. But here some myths had misled ourselves and dragged ourselves down to these crises. And also the general public, they can take share as public. I earlier asked the policymakers to allow public to take their part in self-generation, and it's public's responsibility to take our share in self-generation, the renewable sources. We'll see. Then we are coming to this non-conventional renewable energy. This we refer to as NCRE. Even at I think that lady at my introduction, she mentioned something regarding my research as NCRE. What is this NCRE? NCRE is non-conventional renewable energy. Renewable energy is what we call this Punarjananiya Bala Shakti, that means solar, wind, and biomass. Those are we call as renewable energy. And what is the NC? Non-conventional. The conventional renewable energy is this large hydro power plants. Those are conventional renewable. These are non-conventional. Non-conventional means you will understand. I will explain. The non-conventional means once the conventional renewable energy, all of the sources are utilized, then what we are looking towards some non-conventional approaches. That means this mini hydros, micro hydros, and solar, wind, and biomass, all such things. That those are non-conventional. Then we will see that what is the reason for that. The NCRE, why NCRE is scarcity of fossil fuels. Yes, we heard that fossil fuels are scarce. Then because of the NCRE, the carbon footprint is reduced. This carbon footprint is the amount of carbon dioxide emitted by a person, activity of a person. So that's the carbon footprint. That by using NCRE, one person's carbon footprint is virtually reduced, and that carbon footprint can be calculated per person, per capita, or per nation. Resources are already, as I mentioned, already utilized. So that is why we are moving and researching towards NCRE, non-conventional renewable energy. This is the question. Does NCRE free or cheap? What do you think? Solar irradiation is free. We are a tropical country near the equator, and we got direct sunlight beams, and we are placed in a very good position in the solar maps. So solar irradiation is free and availability is very high. And the potential water heads, yes, in the renewable energy, yes, it is free. No one charges us for the water heads. And kinetics in wind blow is free, isn't it? All are free. Then is it really free? The renewable energy, the renewable electricity generated by renewable energy, is it really free? Why not being vastly used? If all these resources are free, then why this renewable energy, non-conventional renewable energy, is vastly used? Why it is not vastly not used? The reason is this: by NCRE, by the sunlight, we can easily get our clothes dry. And I am doing it. My family is doing it. And I know that even some foods can get dry just fine. Even though the clothes can get dried, we cannot iron our clothes using sunlight, because we need a conversion of energy mode. Energy, the form of the energy we require. It is the convenience we have with the electricity. This energy, form of energy, is the concern. Then the conversion requires higher capex. Sunlight is one of the light, and the radiation is one of the form of the electricity, is a form of the energy. Energy can't be created or destroyed, but we can convert it to some other form. So this radiation of sunlight, energy in the form of radiation, can be converted into the form of electricity. That conversion requires some systems. Similarly, as machine, there are no moving parts, so it's not a machine, but it's a system. That system is solar PV panels. PV is solar photovoltaic. Those panels are required. That has a capex, and the DC voltage is to be synchronized to the grids and our equipments. So then the inverter is required. So those equipment are with considerable capital expenditure, and the efficiency of those panels nowadays it is just reached 20%. That means if we receive 1000 watts per square meter radiation, we can get only 200 watts per square meter out of the solar PV panel. And then losses at the inverters, once incurred, it's a very entire output is still it is at 17%, 16% range. So even the higher capexes are incurred, but the output is still at the increasing range, and it is at the low stage. We'll see then. And what are the limitations in NCRE? Say, for example, I'll tell you that electricity generation is can be categorized into two. One is dispatchable generation plants, and non-dispatchable power plants. What are these dispatchable energy? Dispatchable energy, the generating plant has the control in the generation. Control over the generation. That means when the power plant or the operator requires the energy, he can control the plant and take only the required amount of power out. The control has with the plant. Non-dispatchable energy is the plant cannot control the generation. That means source is controlling the generation. Say, for example, a solar plant, solar panel or the inverter cannot control the generation. The source is sunlight is receiving, then generation happens. To get the maximum out of such non-dispatchable plants, we need to extract harvest as much as possible when it gives. Because when it does not give, we cannot harvest. That's the reason. Even the mini hydro or micro hydro, when the rain the catchment areas receive the rains, the flow of water through the canal is higher, and then the power plant generates at when the water is there. So it dispatches the power. So it dispatches, we have to receive. We cannot control the dispatch. So those are termed as non-dispatchable energy. And the fossil fuels, large hydro, LNG, and solar thermal. Solar is in two forms. Solar plants are in two methods. One is solar PV. What with the photovoltaic effect is used, and those are with the solar panels. The other one is solar thermal. That means the solar energy received to the ground is reflected. Here you will see the higher mast here. That in the third picture at the bottom. This solar irradiation received to the ground is reflected to and focused to a chamber of oil at a mast through reflection by mirrors, and then that oil get heated to a very high temperature like 700 Celsius. Right? It can be stored. That energy is in the form of thermal, and it is stored, and then it uses to generate steam and operate the power plant. So that as the thermal energy of the oil can be stored as in the form of thermal energy. So solar thermal is categorized as dispatchable energy, and while solar PV is categorized as non-dispatchable energy. Those are the limitations of NCR. As this is non-dispatchable, what we need is we need the storage. We need storage to use non-dispatchable energy. We need to a grid. What are the storage methods? Battery banks, and these days the researchers are doing to store it as in hydrogen. Store the energy as hydrogen. That is the most dense mode of energy storage is hydrogen. It is 3 times larger than the energy density of diesel. And also as capacitor banks. The energy can be stored as capacitors. All these are at a cost. That cost are in the form of capex, and it should be depreciated over the years when we are running it as a network or as a grid, and that is to be again collected from the consumers. When compared to the capex of these, when capex of these are compared with the capex required for fossil fuel plants, these are at a very high end. So a country like ourselves has very less possibility to afford these economically. The cost of generation for a unit is very high with this. As that question asked from me, when the tariff is increased, it will be whether it will be absorbed by the public. Yes, those are the concerns, but we can do it up to some extent with the mix, not changing entirely towards one name, but we can have a mix of all these generation patterns. One other thing, the last picture at the bottom, the most bottom right hand corner. This is an interesting arrangement. This is a pump storage. That means, say for example, solar and wind, they are available at the time that which they are dispatching. That's non-dispatchable energy. Here, this pump storage, it says, the concept is when this renewable energy is available, we can use that energy to pump the water from a lower reservoir to higher reservoir and store it there. Then storage is in the form of potential energy. That's possible. And when the demand is high, we can use the higher reservoir at the higher level to generate electricity by the plant as a hydropower. That is a way of another way of storing the excess electricity in the network to use as and when we require, and converting the grid virtually to dispatchable. Those are alternate methods. On the other hand, as that, I think it's Prasanna that who asked that question, as I remember, when the tariff is high, what will happen? The general tariff is placed at a higher, considerably higher position, or at least it reflects the cost of generation. The people will tend to evaluate and invest on these renewable sources. That is how I'll come here. Then only the public will take the share of self-generation. As of now, I do not think people would invest a rupee and expect a return of 90 cents. The people are investing for return. The return on that's how businesses run. So if there is a 1 unit of electricity available for at a cheap rate, why would the person invest some money on the electricity generation to get the unit at a cost higher than that? No requirement. So people won't do that. So if by having a tariff structure which reflects the correct generation, transmission and distribution, so the correct cost is embedded into the price, then people, if people has the possibility, they will tends to find alternatives. That is the negative feedback path I have mentioned, that in the control system we mentioned our forward path is HX and the feedback path is GX, and the negative, without that negative feedback path, no practical control system is sustained. The control system does not means that everything is machines, the gear wheels and electronics. Even a society is a control system. No control system will sustain without having a negative feedback path. That is why how we have discussed it. I think now it is the time for audience. I think the time that the Felon has asked me, I have taken 10 minutes additional. Still, I am fine. Any of you can ask some questions as we require.
Thank you so much, Mr. Anupama, for that insightful session. It was a great help for all of us to expand the scope of renewable energies. We have now arrived to our Q&A session. You all are welcome to come up with your doubts and questions. So we have a question. How the distribution of energy resource adoption is impacting resources adequacy planning. Can you please explain it?
Can you please repeat the question?
Yeah, sure, sir. How the distribution of energy resource adoption is impacting resources adequacy planning. Can you please explain it?
Distribution of generation resources means that, say for example, I'll come. Oh, slide has gone. It's fine. Okay. There are two aspects. One is we are an islanded nation, which is spread over just between 4 longitudes. So we have just a single time zone and just practically 8 minutes difference between Colombo and Batticaloa, but we have at a single standard time. But say for example, a grid like Europe or grid like India, it has the distribution, geographical distribution, when one area, one particular area is at the peak time, the other area experience a valley in the demand. And when that area is spread, the generation and the transmission losses are less. And when the grid is spread over several longitudes, the peaks and valleys can be very easily managed. But when you see, if you can remember the demand graph, the daily demand curve in Sri Lanka, it has a valley and a peak. So we need to have an installed capacity to match the peak demand, but most of the installed capacities are idled at when we are experiencing the valley. So that managing and leveling this valley and peak is very easy when the geographical spread of the grid is high. In the generating sources are spread over the geography, it means that the transmission losses and the distribution losses are basically transmission losses are less. When we come to the distribution in terms of the type of sources, yes, it is very important to a generation grid, because say for example, have you ever thought that when this peak takes place, generally it starts at 6:30, then when that peak takes place, how the controlling of the generation is happening? Because the generation part, that the generation unit does not have a control over the demand, but it is driven by the demand. When the demand is increasing, the generation should be in par with it, and it has to increase the generation. But how it happens? When say for in a particular area, one megawatt or several megawatts, demand of several megawatts is increases. So how it happens? It should take some time to increase the generation, but predicting it, the controllers cannot predict it and increase the generation at first. First, it should be the demand, increase in the demand should be felt to the grid. Then only it happens like this, because the sum of say for example a hydro plant or a steam plant, that the rotor of the generator, it has a very high inertia. The energy stored in the rotating rotor, that armature, is half I omega square. So that omega is the frequency of the net. It relates to the frequency of the network. What happens is, when the demand is high, the energy stored in the rotor is delivered to the network initially, and in the meantime, very quickly, the firing of fuels is increased, or the water jet, the size of the water jet is increased, and again the rotor is taken into the appropriate speed to maintain 50 volts. That is why the tolerance of the frequency is given 0.5 hertz plus and minus bit to 50 hertz. So such inertia power plants with inertia is required to have a stable generation network, stable grid in the generation network. But if these renewables, say for example solar, do you think the similar thing can be done with solar? No, it does not have that inertia part, the storage part. But with such methods we can do, but we need higher storages for that. So the distribution of sources in terms of the type of generation is essential to the grid. And if the distribution of generating sources, geographical distribution is a blessing to manage the network. I think I have answered you.
Thank you for the explanation, sir. So we received another question. Can we substitute electrolytic hydrogen derivatives such as ammonia, synthetic methane, or renewable diesel for traditional fuel in combustion turbines? Shall I repeat the questions?
Yeah, I got the question. I got it. Yes, there are possibilities, but those are to be researched and checked with the specifications of those power plants with the manufacturers and their details. And there may be some modifications are to be done to these plants to accommodate that. However, one cannot reject that that cannot be done, because we know even some plants, some combined cycle plants which we have at present are capable of using LNG. So those multiple the fuel variety of fuels are possible with some plants. Yes, that is possible. Those are the research area, and that is the duty of engineers and engineering students on the as researchers to check on the possibility to help the nation to come out of this crisis.
Thank you for the explanation, sir. Thank you for cooperating in our Q&A session. This is a kind reminder to all of our participants. Stay with us till the end of the session to join for the group photo. As all good things comes to an end, we are in the final part of our wonderful session. We would like to give you a token of appreciation at the end of this session. Mr. Anupama, we are truly grateful for humbly accepting our invitation and spare your valuable time to guide us and to motivate us throughout the session. Once again, on behalf of IES of SLTC IEEE Club, we are much obliged to receive your valuable knowledge and wisdom. With that being said, I would like to welcome our project secretary to deliver the vote of thanks.
Thank you, Sinali. A very good evening to everyone who are present here today with SOLUTIA-E. I'm so glad to get this opportunity to thank all the dignitaries who are present here today. On behalf of the organizing committee of SOLUTIA-E, I would like to express my gratitude to all the participants who are here with this webinar for their presence and also the contribution to make this event a great success. First of all, I would like to express my heartiest gratitude to our most honorable guest speaker today, Mr. Anupama Silva, for the delivery of a wonderful and amazing session about how to face the energy crisis. Sir, thank you for the great insight that you have shared with us today. And I hope, and I definitely know that all the participants were greatly benefited by this interesting session. I'm also utterly grateful for all the student advisors of Project SOLUTIA-E. And also, I would like to thank the executive committee and executive committee members of IEEE student branch of SLTC for their great support and also the assistance that they have given us. And this amazing event can't happen overnight. It was only possible because of my fellow colleagues of the organizing committee. So I would like to thank the organizing committee of Project SOLUTIA-E for their hard work and their dedication and their great efforts to make this event a massive success. I would also thank the moderator of this evening, Sinali Kularatna, for her effort towards the success of this webinar. So once again, thank you everyone and good night to all. Over to you, Sinali.
Thank you, Pavasara. It's time to take the group photograph to remark this wonderful evening. We would like to kindly request to switch on your video cameras to participate in the group photo.
I think it is time that I can leave. Hello.
Thank you for your collaboration. See you in another amazing chapter of IES of IEEE SLTC. Until then, stay safe and have a wonderful evening.